Consider the following reaction at a high temperature. Br2 gas equilibrium to Br. When 1.70 moles of Br2 are put in a 0.880 liter flask, 3.40% of the Br2 undergoes dissociation. Calculate the equilibrium constant Kc for the reaction. Now, in order to do this, we need the concentrations of Br and Br2. First, we're going to find the original concentration of Br2. So the concentration of Br2 is equal to 1.70 moles over 0.880 liters. That'll give you 0.193 molarity. And of the original 1.70 moles that we were given, 3.40% have dissociated. So now we're going to have to find the molar concentration of Br2 that has been dissociated. Now in order to do that, we're going to multiply the same fraction we just used. Which is 1.70 over 880. And we're going to multiply that times 340 out of 100, because 3.40% of our Br2 out of 100% of it has dissociated. So that'll give us 0.0657 molarity of Br2 that is dissociated. Now we need to find the concentrations of Br2 and Br at equilibrium. So let's set up an ice table. You have your initial, your change, and your equilibrium. This is all in molarity. Our units need to be in molarity in order to use the ice table. So let's write our equation up here. Now we started with 1.70 over 0.880, and that equaled 1.93. That's Br2. So for 2Br, we didn't have anything, nothing had reacted, so there was nothing there to begin with. So we're going to put a big fat 0. And we lost 0.0657 dissociated in our Br2, so the change would be negative 0.0657. And we gained 2 moles of it, so we're going to multiply 2 times 0.0657. And that'll be the change over here. And so our equilibrium, after all said and done, you subtract 1.93 minus 0.0657, and that will be 1.87. And then you add 2 times 0.0657 to 0, and you're going to get 0.131. So now we have our concentrations, and now we can plug this in to get our Kc. So we're going to do products over reactants. And that'll equal Br to the second power, because the substituent or coefficient, there we go, over Br2, and that has a substituent. So let's plug in those numbers, and 0.131 squared over 1.87, and our final Kc will be 0.00923. And that's how you get your Kc.